This is Group 3 for techniques in high fidelity single acquisition, and this is our project that we had. We worked on a Arduino based ECG system, and we used a SparkFun 8232 that we had to figure out how to make it work better than it actually does at this moment in time. With it, we had it connected to an Arduino Uno, and there was only about 5 wires that needed to connect between the two to get it to read a serial monitor. As we see, there's a little flashing indicator that's reading a heart rate. Reason why is it's because it's attached to me at the moment, so it's reading my heart rate right now. And along with that, we will get out of this and we will look at what it's reading. Now, the Arduino had in GitHub a SparkFun AD8232 system already set up to read, so we utilized that in order to pull the data, and to see it reading, we went into the serial plotter. Okay, hold on a minute. It says serial monitors open, so I have to shut one of them before I can open the other. Okay, so first we went into the serial plotter to just make sure that the data we're getting looks like a normal EKG or ECG. And we got a pretty clear picture. It was a little bit clearer when we started because we had clean pads, but now get a little bit more movement, and I'm also talking, and that can give a little movement with the EKG too. But we can see individual beats going on in the different segments. But we want to make it clear, so that's what we tried to do with this project. I'm going to close this plotter, and we're going to look at the serial monitor. And what that does is it just pulls up the data that we're receiving. And with that data, I actually saved it to a data sheet, just an Excel file. And this is just old data and an old image of what that data looked like. And using that data, we went to MATLAB and tried to figure out a way to filter it, seeing that the device itself already contains an amplifier with a gain of 100. So it's actually already doing the amplification need that we were trying to find. And it also has filters in it that are getting a majority of the noise already reduced. So how do we reduce it more? We went into MATLAB and we used that data sheet and we pulled the information, and we did a low-pass Butterworth filter on it to get cleaner values. So what I did is I have about 4 different plots that I used. First one is comparing the original data to the filtered data. The second one's just giving us a Bode plot to give an idea of what the image is doing as well. And then I have individual figures where it shows filtered versus unfiltered. So as we run that, the values that we obtain are the transfer function that it comes up with. And then we also get the new filtered data pulling up on the side here. One thing we notice is that the first 4 measurements or so, 4 or 5 measurements, actually are extremely low compared to the rest of the data. So that may be skewing our transfer function a little bit. Along with that, transfer function is mainly a second order Butterworth filter. And some of the images that we obtain from MATLAB, we'll go with the Bode plot first. This is just an image of how it's working with the Bode plot. Then, if we look, amplitudes are pretty similar. The blue is the filtered, so we're losing a little bit of the peaks on the values. So the maximum value has decreased a little bit, but the rest of it stays pretty similar along the rest of the trend lines there. When we go to individual values, we look, this is the original noise. Let me pull that to where we can see it better. Hold on a second here. Come on. Okay, so we open up, this is the noisy version that we have, and then we pull a filter out and we get a filtered version. One of the issues that we see, those 5 initial readings give us a nice skew right here on the bottom that just throws off most of your data. So, but beyond that, it gives us a nice cleaner image that's pretty similar to what we're supposed to be looking for. So that is how we were able to change our system and make it better. It would have been nicer if we were able to create a database and put it on a website to where it would read and give us a heart rate and everything, but time was not permitting for that. So this is our change that we were able to do with the system with what we had in time. Thank you and enjoy.